On this next part, so today we're going to talk about systems of linear equations in two variables. And a system of linear equation is a group of equations, always more than one equation in it. It could have many equations. And right here we have an example of a system. This one is x plus y equals 7 and x minus y equals -1. Here we have a point, and we know that this point is a solution to this system of equations because if I replace the x and the y with the 3 and the 4, which we have here, we find that 3 plus 4 is 7, which equals 7, so that point is indeed in this line. And if we were to do the same for the second point, 3 minus 4 equals -1, -1 equals -1, so therefore this point is also in the second line. So it is a solution to the system because that point is in both of those lines. Here I want you to take a moment and see if 2, 3 is in this solution. I'm going to pause the video and we'll come back and check in a second. So if you went through and actually put 2 in for x, 3 in for y, you got 2 plus 3 times 3. And then 2 plus 9 equals 11, and 11 does equal 11. So it is in the first equation. And also, if you do it for the second equation, 2 minus 5 times 3 equals -13. And in the end, it does, -13 does equal -13. So this is a solution to this set of equations. Now, we want to do the same thing for this one. I will pause the video here and give you a moment to try it out. Notice that the first equation does come down to 2 equals 2, so it is indeed part of the first equation. But looking at the second equation, look what happens. We have -4 minus 6 equals 6, and then -4 plus a -6 is a -10, and that does not equal a 6. So in this case, this is not a solution to these systems of equations. What we're going to do is look at two lines and find their solution by graphing. Okay, so on this first set of lines, what form of lines is that? This one's standard. Yeah, these are standard. And the other one is what? Slope-intercept. Okay, so for slope-intercept, if I'm going to graph that one, what's the first thing I'm going to graph? The intercept, the 5 in this case. So I will put a dot on the 5. And what's my slope for that one? There's no number in front of the x. What does that mean? It's a 1. You can assume a 1 here. So my rise and my run are both 1. I'm going to rise 1, run 1. Okay. Now if I connect my dots, and when you're doing these, make sure that you extend your line as far as you can on the graph because you might have a solution way off in the distance. Okay, so extend it as far as you can. On the second one, what's my intercept? That's my slope. My intercept is 3. Yep. And since my slope on this one's a negative, it's a -1, so I'm going to go down 1 to the right 1. Okay, connect my dots again. Oops. Yeah, question? You always go to the right. You might go up or down, but you always go to the right. Okay, so where is my intersection here? Yep, -1 and 4. So my solution for this set of equations, -1, 4. That's the only point they have in common. Okay? Yeah, not too bad. The next one's a standard form. What is the easiest way to graph standard form? Okay, I know that you can always solve for y and graph it the same way, but that's adding a lot of steps to this. What's the easiest way to do this? Okay, so graph by intercepts in this case. Okay, When it's in standard form, you will save yourself a lot of time by graphing by intercepts. So if I take my first one right here, 2x minus 3y equals 6, and I put in 0 for x, my x goes away, right? I'm left with negative 3y equals 6. What's y going to be? Negative 2. Okay, so I'm going to put my first dot right here. And then on the second part, if I get rid of my y by putting a 0 in for y, I have 2x equals 6. What's my x going to be? 3. So I will put a dot on 3. See how much easier that is in solving for y? Okay? You'll save yourself a boatload of time. There we go. Do the same thing for the second one. So I have 4x plus 3y equals 12. Yep, so if I cancel out my 4x, I have y equals 4. Let's put that on here first. And then the other one is 4x equal to 12 and x equals 3. So connect your dots. Where do they cross?
3, 0.
Yep, exactly. They cross at 3, 0. So my solution in this case, 3, 0. Okay, so before we graphed to find the solution, this time we're going to actually solve them by substitution. So our first step for these is to solve either of the two equations for one of the variables. In this one right here, it's already solved to one variable. So I'm going to say that's done. Okay? The second part says substitute the expression from step 1 into the other equation. Well, I know my y equals 3x minus 7. I'm going to put that into y. So it's going to be 5x minus 2 times 3x minus 7 equals 8. We need to solve for x. Because y equals 3x minus 7 here, so I can just substitute it in for y here. Replacing y with that. Okay, so that's going to be 5x minus 6x plus 14 equals 8. Well, 5x and 6x can go together, so I have a negative 1x. Not 8, but 14, right? I need to get the x alone, so I'm going to take 14 from both sides. And if I do that, I'm going to have 8 minus 14, or negative 6. Well, I have negative 1 equals negative 6. Negative 1x equals negative 6. So what's my x going to actually be in this case? Yep, it's going to be 6. Okay, so that's my first bit right there. I know that my x equals negative 6. Now, or positive 6. I need to find my y. Plug it back into the y. I'm going to write it right here. Y equals 3 times 6 minus 7. Well, 18 minus 7 is what? 11. So my point is 6, 11. Okay? That's the solution to both equations. So we will do the same thing with the second set, except that notice that neither of the equations have solved for an x or a y. So which equation am I going to take to solve for one variable? Which one would be easier? The bottom one would be easier. Now you can do either one, but if you solve the top one for x or y, you're going to have a fraction, and who wants to work with fractions? Okay? So let's use the bottom one. I want to solve for x. What can I do to do that? Plus y to both sides. So my x is going to be 3 plus y. Okay? So now I'm going to substitute that in back into the first equation for x. So it'll be 3 times 3 plus y plus 2y equals negative 1. If I distribute this, it'll have 9 plus 3y plus 2y equals negative 1. What are my y's together? 5y. Now what? Yep, so I'm going to subtract a 9. So it'll be 5y equals negative 10. So what's y going to be? Negative 2. Okay, so now I know my y is negative 2. What am I going to do now? Plug it back in to this equation, right? So x equals 3 plus a negative 2. So that's 3 minus 2 is 1, right? That's a negative. It didn't come out very well. So my point in this, my point of solution is 1, negative 2.
So it's nothing to do with the first upward part. You don't plug in anything.
No, I don't need to, because I maneuvered everything around over here, so I can use this one, okay? This is really the same equation as this. It's just changed places in it, okay?